In this part, we will introduce WLAN transmission channels. WLAN signals are transmitted in two ways. First is radiation, and the second is conduction. And at this part, we will focus on the radiation. And at this page, let's see a concept which is called channel, WLAN transmission channels, where the channels are based on cables, while WLAN wireless channels can be seen as RF. Channels uses wireless RF signals as medium to transfer signals. In this picture, it shows us the whole process that the WLAN transmits some data from the source to the destination. For example, from the signal source, after modulation, it will be transferred to the radio transmission device. And for example, an antenna. And an antenna will set out signals. These signals will be transmitted via channels or via media and will be received by the radio receiving device. And after demodulation, it will be received by the signal host. So the whole process is like the signal source sending through channel and be received by the signal host. Okay, after knowing this process, let's see some concepts. First is band. Band refers to a certain range of frequencies. So it's a range. AP uses 2.4 and 5.8 gigahertz. Actually here, 2.4, 5.8 are two, you can think are two bands, or you can think they are two ranges. The 2.4 gigahertz band refers to the frequencies in the range of 2.4 to 2.4835 gigahertz, right? And in this band, it contains multiple channels. A signal of an AP uses a specific channel of the band. So since we have mentioned the channel, so let's see what's that. If an AP uses the 2.4 gigahertz band, it uses the frequencies in the range of 2.4 to 2.4835 gigahertz. In this band, there are 14 available channels, and the center frequency of each channel is 5 megahertz apart from each other, and the bandwidth of each one is 22 megahertz. Okay, after knowing these two concepts, then let's go on. Another concept, which is called bandwidth. Actually, even in the wired network, we also talk about the bandwidth. For example, the bandwidth of a link or of a cable, right? And each band has a specified bandwidth, which is a weight of all the available frequencies. Bandwidth indicates the data transfer capability of a link. It's the same as that in wired network, right? The greater the bandwidth, the more data the link can transfer in a specific period. The term wireless channel is a metaphor for the link between the signal transmitter and receiver in wireless communications. So let's see, generally, WLAN use 2.4 and 5 gigahertz bands. The bandwidth of each channel is, for example, 20 megahertz, and there is a 5 megahertz margin between the two channels. Wireless devices can use only specific frequency bands, and about the frequencies that they can use is different. Let's see. Here, at this page, it shows us the channels in 2.4 gigahertz bands. And from this picture, you can easily find that in the 2.4 gigahertz bands, we have 14 channels. And the bandwidth of each one is 22 megahertz. And the center frequency of each channel is 5 megahertz apart from each other. So from this picture, you can see the channels is listed here one by one. Adjacent channels overlap each other, right? It's obvious from this picture. So if we use the adjacent channels in maybe in a small coverage, it will bring maybe interference. So only three channels: channel 1, channel 6, and channel 11, which we have marked red in this picture, do not overlap each channel. So if you want to use three channels inside maybe an area, we prefer you use channel 1, channel 6, and channel 11. So there will not be interference. Okay, this is about 2.4 gigahertz. And then let's see the reuse of channel in the 2.4 gigahertz. APs use 20 or 40 megahertz bandwidth, right? And we just mentioned that if we use 20, we have 14 channels in the 2.4 gigahertz band, right? But if the bandwidth is 40, actually the number will be reduced. The 2.4 gigahertz band contains 13 channels which overlap adjacent channels. So therefore, WLANs in the same area often use channel 1, channel 6, channel 11, right? As shown in the figure you can see here, the bandwidth of them is 20. And if we extend it to 40, only two channels are available for non-interfering communication between APs, right? Because the number of channels are reduced and the bandwidths are improved. So the only two non-interfering channels can be found in this band. Okay, after introducing the channels, then let's see. Actually, since we are all using 2.4 gigahertz band, but in different regions or in different countries, the frequencies they can use are different. You can see for example, in Europe, in China, in Japan, or in the US, in Canada, the channels that they can use are a little different, right? So these channels or the 2.4 gigahertz band are governments granted, okay, are strictly managed by the governments. Okay, and in 5.8 gigahertz band, let's see it. WLAN devices use 5.8 gigahertz band containing the frequencies in the range from 5.725 to 5.850 gigahertz. And the available bandwidth of this band is 125 megahertz. There are 25 channels. Yeah, we can count it, right? 25 channels are available. And in this list, it's showing us 5 of the 25 channels do not overlap each other. Each channel number is showing here: 149, 153, 157, 161, and 165. You can see their frequencies existing here. This is about the 2.4 gigahertz. Actually, nowadays, when we use WLAN, we can receive 2.4 gigahertz signals, and we can also receive maybe signals which works at the 5 gigahertz band. And how do we choose it? For example, in which situation we can choose 2.4 gigahertz, or in which situation we prefer maybe 5 gigahertz. Let's see the advantages and disadvantages of them. First is advantages of 2.4 gigahertz Wi-Fi. It uses a 2.4 gigahertz band, right? So the first advantage is that it has better signals compared with 5 gigahertz, right? So the signal is better. And a basic physical feature of electromagnetic waves that the longer the wavelength, the less the attenuation. This is the reason why the signal is better. And the 2.4 gigahertz Wi-Fi has relatively low frequencies and low wavelengths. Therefore, signal attenuates less than 5 gigahertz Wi-Fi. So this is an advantage. While the disadvantage, let's say, 2.4 gigahertz Wi-Fi has a relatively narrow bandwidth. It's mainly used by home appliances and wireless devices. has a high interference due to a large number of devices using this band. So the advantage is better signal, but the disadvantage is maybe interference, right? And the narrow bandwidth. Okay, next, let's see the advantage of 5 GHz Wi-Fi. 5 GHz has greater bandwidth, right? And it features stable connectivity, little interference. So actually, this is 5 GHz advantage. And next, let's see the disadvantage. 5 GHz Wi-Fi signal has high frequencies. So high frequencies brings that the attenuation is high, so it will affect the signal of it. And the coverage of the signal is smaller than 2.4 GHz. It has poor capability in penetrating walls and attenuate greater than 2.4 GHz signals. So it's suitable for small indoor WLAN and outdoor wireless bridges with no worries for WLAN accesses by knowing sources. Okay, so from this page we can know that if you need high speed, if you need maybe stable connectivity, you can choose 5 GHz band. But if you, for example, if there are some covers or if you are in a complex building and you think that this signal is very important, so you can choose 2.4 GHz. Okay, this is about the comparison between these two bands. Okay, so after introducing all these contents, let's say a practice question. Okay, let's do a summary. Which of the following is not the advantage of 5 GHz Wi-Fi? A. Greater bandwidth. Yes, this is one of the advantages. B. Stable connectivity. Yes, it is. C. Less signals attenuation. D. Little interference. Okay, obviously, the attenuation of 5 GHz band is greater than that of 2.4 GHz. So we choose C. Okay, that's all for this part.